J, hence J-pole. And then this antenna is the same bands as that antenna. So this is UHF, VHF. But this is a full wave antenna. So this is a 2 meter, 70 centimeter antenna, and it's 2 meters tall about. And this is a choke point right here. This is a choke, and so what this does is separates out the two bands, but allows them to pass through the antenna at the same time. So this is a resonator. They call this a resonator. This is the bottom part of the J right here, and this is the feed point. All antennas have a feed point that can transmit, and so this antenna is omnidirectional, so it's basically everywhere around the antenna, although it has some directionality with this J here. And so the math on this is really unique too. So the math on this says that the receipt of the radio waves is in a full wave for both sections of the antenna. So they add up to 2 meters, but they're separated out into one is 70 centimeters. And then what this antenna, the other math on this antenna is this resonator down here, when a current is passed through this antenna, the magnetism changes, and so it emanates a wave. And the wave, if I were able to draw it, would be something along the lines of, would proceed out from the J here, traverse the antenna, and then wrap back around the top of the antenna. And so if you were to imagine a wave emanating from this antenna, would be
so this is both sending and receiving, yeah, right? And the wave, so each of the two is a tuning fork essentially to a particular portion of the electromagnetic spectrum.
That's right.
And those represent the relative wave sizes.
That's right.
In electromagnetic spectrum. And so what would you do with the big one versus small? What are the characteristics which distinguish those two?
VHF, two different bands on the same antenna. UHF, ultra high frequency, is best for if we're transmitting in a building. If you want to transfer it through confined spaces, a lot of construction workers will use UHF for transmission inside of buildings. UHF is more a broader open area line of sight transmission than UHF. So they have two different kind of unique purposes, but at the same time they have different purposes, but they're both good for line of sight. We should say that. Some are good with obstructions and some are not. So.
And you just got these plans on the internet and assembled them to the specific measurements, and then you hook it up to your radio, the little radio you bought on the internet or whatever, and it works good?
It works great, yeah.
Yep.
There's they measure the way to calibrate an antenna is with a meter called a standing wave ratio meter, SWR. And we know a good antenna when it is about 1 to 1 to 1 to 2. So what that means is basically if this antenna, if you press the transmit button on your radio, what that is doing is allowing most of, if not all, the wave to be transmitted out of the antenna with no reflection. So if there's reflection, then your radio gets gummed up and you don't get, you get reflection, then basically
feedback.
What's happening is the current is coming back to your radio, and that'll fry your radio. So you want to make sure that when you tune your antenna, you want to make sure you get the right SWR out of your antenna. So you do that by putting the SWR meter between the radio and the antenna, and it measures for you.
So is there anything that we can do if we don't, can we make something and then listen rather than if we don't have a license or don't want to go through the license? Or how hard is it to get the license that you were talking?
The license, I mean, it depends. If you're in the math and sciences, you could probably go take the test and you could probably do fine. That's not entirely. You have to know you got to refresh yourself on Ohm's law, basic electronic circuitry, and some basic physics and stuff like that. But otherwise, it's pretty good. And the FCC has particular rules and regulations that they want you to obey. Basically, no selling things on the radio waves. Use common language. When you talk to somebody, you have to use your call sign. Things like that. So they want you to know a certain bag of regular laws that they need to use on that.
How many any credibility in the job applications?
I'm sorry, what's the question?
Does it have any credibility in job applications?
Well, you know, I mean,
on your resume.
Yeah, my call sign's KB1CKK. I'm a
Probably not a big developing field is amateur radio, right?
If you're in communications, you probably have some familiarity with this from as an application rather than a profession beforehand.
Yeah.
So, you know, a lot of people who start out in amateur radio as young people usually end up going into communications. So, it's a good outlet for somebody who is social by nature, is technical by nature, and it's a great way to meet people. I mean, there's clubs. There's Eels Hill Road in Milford over here. There's a Nike missile silo over there with 4 buildings on top of it, with a radio club hanging out in there, and they've got this humongous antenna on the roof, and they just have a great time. So it's a wonderful way to meet people. It's a great group, and they're very innovative people at the same time. So some of the radio old timers, you know, they've forgotten more about, you know, physics and electronics and radio and things like that than we'll ever know. I mean, there was an Apollo mission, I think it was Apollo 13, and they were sitting around mission control, and something was going on inside the cockpit of the capsule, and it was about to be mission abort, you know. And so one of the old timers there is like, you know, so the countdown's like T-minus 2 seconds. You can see it on the internet, and he says something's I've got feedback through the radio. Communications are going to be cut off, you know, and he goes switch to aux 2, and he pushes the button, and that's it. They launch the whole thing. So there you go. You know, switch to aux 2. So, but yeah, these are fun antennas. And
wait, this is someone who you met?
No. My Uncle Jimmy inspired me on antennas and radio, though. I mean, he worked on the Apollo missions at Pratt Whitney, and I went over there and had that little radio, and he said you should stretch out a piece of wire in the backyard, and so I did, and then I was listening to like Radio Romania.
How much does the oxidation on the J-pole here?
Nothing really. It just doesn't really make a difference at all.
Okay. I also noticed that up around the choke point, it looks like you've got it looks wobbly up there. It looks like it might be threaded on. Does that affect it at all, or am I just?
No, I mean the current passes through this choke point on the wire only. So the wire wound portion of the choke point is where the current travels, and in between that connector is an insulator.
Okay.
So it's a little wobbly because there's PVC underneath there.
I got you.
So it's not metal all the way through.
Okay.
Yeah. It's not metal all the way through. It's
Cool.
insulator.
So you said that